So the title is Horizontal versus Vertical Shrinks and Stretches. The first thing I want you to write is, watch this, horizontal shrink when, going to put horizontal shrink when. Help me out. I'm talking now? No more talking. Write the words horizontal shrink when, then put a colon after. When does a horizontal shrink occur? Well, let's see. Let me get my Desmos.com here. Watch this. Let me get a Desmos.com going. Here's my parent function. Look what I'm going to do. What I'm going to do is I'm going to add an h value. When I say h, remember that's the number after the x. Let me put a plus. Let me put a plus 7. Right now you don't have to write this down, just pay attention. Right now all you have on your notes is horizontal shrink when. That's all you have right now. Right now you're going to just pay attention. Watch this. Look what I did. I added an h, and that's plus 7, so I have a horizontal shrink to the left 7. We know that. Now look what I'm going to do. I'm going to pick a number that's greater than 1, and I'm going to put it right in front of the x, but inside the absolute value symbol. Let's see what happens. I'm going to put 4. Actually, let me keep the same one. I'll put it over here with a different color. Let me copy and paste. I'm going to Control-C, copy. I'll put it right here. I'll paste it. But now I'm going to put 4 in front of the x. Look what happens. I'm going to put a 4 right here. How does that compare to the previous one? Look what happened. Here's the original. Then I put a 4 in front of the x inside the absolute value symbol. Look what happened. You have the same y-intercept. Look at, they both cross the y-axis at the very same place. So what happened is that this one shrank horizontally, not vertically. It shrank horizontally. So horizontal, when I say the words horizontal, I'm talking about left and right movement. Vertical is up and down movement. So what took place from the original, just to x plus 7, is we have a horizontal shrink by a factor of 1/4. Let me pick a number greater than or less than 1. So look at 4 was greater than 1. What about a number less than 1, but higher than 0? So a fraction. Less than 1, but greater than 0? What's the first fraction that comes to your mind? Give me one. Give me a fraction. One more time. -2/1? That would be -2. So I need something greater than 0, less than 1. So give me a fraction. 1/2. Look what I'm going to do now. Look at the third graph. I'm going to put a 1/2 in front of the x. Look what happened. Check it out. Look at the bright orange now. The original was in red. When I picked a number greater than 1, look at it in green. Look at 4 is greater than 1, and it became a vertical shrink. Not vertical, I can't say vertical. It's actually horizontal. This slid over here, so it's a horizontal shrink. Look at they all have the same y-intercept. Every single graph so far, the 3 of them, they all cross the y-axis the same way. So it's either sliding closer to the y-axis or away from the y-axis. If I get an a value that's less than 1 but greater than 0, which is a fraction, less than 1 but greater than 0 will be a fraction, I get a horizontal stretch. And look at the orange. I took the original, stretched that puppy by a factor of 1/2. You see. So let's summarize. Here we go. When is a horizontal shrink realized? Then. Check this out. Write this down. Here we go. Let's summarize what just took place. F Oops. I'm going to get Dodger Blue since they win yesterday. I'm not sure. Anyway. They got smacked. Oops. Here we go. Here we go. So, horizontal shrink when we'll write f of x equals absolute value of ax. Notice how the a is inside the absolute value symbols now. That'll be a stretch if, watch this now, if, let's describe that a now, if it's bigger than 1 or less than 1. Watch. If a is greater than 1, so any number that's bigger than 1, like 2, 3, 4, 5, 5.5, 6.5, right, Ortiz? By a factor of 1 over a. So I want to give you that stamp. You got to be paying. You got to be. My bad. Here we go. How about a horizontal stretch? What happened to the stretch? Well, f of x equals absolute value of ax when, let's describe a, if a is greater than 0, less than 1. By a factor of a. Go to write that down. Let me get your. Oh, you got one, Rocha?
Yeah.
So if a is greater than 1, you got yourself a horizontal shrink. If a is less than 1 but greater than 0, in other words, a fraction. This is a fancy way of saying a fraction. Right here, that's just a fraction. If a is a fraction, you're going to have a horizontal stretch. And you just saw that right now with the graphs I just put up. I'll show them to you again as soon as everyone's done writing. Does it? It does. That's pretty much our notes. Almost. Hold on. So back over here. Ready, Ortiz? Rocha, stay with me. So the orange, on the orange, Ortiz, I'm talking, a is less than 1 but greater than 0. Therefore, the red graph stretched. We got to stretch horizontally. It's stretched. Horizontally, I pulled it so it opened up. Look at the bright orange comparison to the red. If a is 4, that's greater than 1, we have a horizontal shrink. That's why the green is thinner than the red. Here's what you're going to do for your seesaw. On your seesaw, you guys know, for your seesaw activity, you're going to create a value of a that's in front of x inside the absolute value symbol, and then you're going to create one value of h. Remember x minus h plus k? Just like yesterday, you're not going to worry about a k. You're only going to make one value of h, and then you're going to fool around with a values this time. Okay? But you're going to add voice this time. You're going to describe to me why did it shrink or why did it stretch horizontally. I put one, please don't do that. I put one example on it. You can look at my example and follow the master. It's very easy. The directions are very clear. You have to, yeah. You don't, because you're going to catch up.